So last week I did a trial run of synthesizing sodium hydroxide. At the time there was 3 things I did not know about this substance. Number 1, it's kind of caustic. Number 2, it can bond with aluminum. And number 3, it does a bunch of stuff that I did not know about. To put things simply, I had no clue what I was dealing with, and did everything wrong. The first mistake was the usage of metal electrodes, which, using that was such a bad idea. It's so dumb. First and foremost, stainless steel can contain things in it that make it stainless, you know what I mean? It's like an alloy of like magnesium, some chrome in there, some iron in there, and all of those things could have ended up being in the solution and being something I do not want in there. An impurity. So first, we add salt to heated water. Now this water isn't heated because I forgot to do that, but don't worry because I heat it eventually. Which then will add the new electrodes, the graphite electrodes, into this solution, which will prevent any foreign contaminants from entering there, as graphite is fairly inert. Although I was kind of worried this graphite wouldn't be conductive enough. However, you'll see in a second that it did produce some gases. And you can even see potentially some of the vapors. I don't think there should be vapors coming off, but there was vapors coming off. Either it's water vapor or something else, because this is hot water. So this is kind of, I wouldn't recommend trying this for yourself, because it produces hydrogen and chlorine gas. Although I was using pretty good ventilation. Another important thing to note is that if you were to do this yourself, then do not, under any circumstances, ignite the hydrogen gas, as it could react with the chlorine to form hydrogen chloride. I was going to say hydrogen fluoride, but that basically similar stuff. Hydrogen chloride can be bubbled through water to produce hydrochloric acid, which implies that it is, of course, water-soluble, which in the case of chlorine is technically also true. So I had this whole thing plugged into the wall, which, yeah, be careful with that kind of stuff. But eventually it stopped, and I was like, what do I do now? Well, what did we do last time? Boil it. Or you could try evaporating it, but that's kind of dumb, because it would take forever. And this is where the big mistake comes into play, but we'll get to that in a second. So, before we get to the big mistake, you gotta understand 2 things. First of all, glass. Second of all, sodium hydroxide. So, yet again, sodium hydroxide ruins my day. And I'm boiling it, right? I look over, decides to explode. Now, this is 2 things happened here. The sodium hydroxide weakened the glass, as this stuff is incredibly caustic, apparently. And also, this isn't borosilicate glass. This is just like regular glass, regular silicon dioxide. This is some sad glass. And of course, glass expands when it's heated, just like every single other thing on planet Earth does. Everything in the universe will expand if it's heated, and will contract when it gets not heated, unheated. What happens when something brittle expands? Well, it just decides to explode everywhere. Wow, that was such a brilliant idea of me, to put glass directly on a stovetop. Wow. So I've always underestimated how much pressure steam can build, but putting my hand over the bottle, I was able to feel while it was boiling the steam, the pressure of the steam coming out. That had some pressure to it. So you'll see these giant trains. These things are heavy, right? Steam trains? Yeah, they can definitely be powered by steam. I would say that 100% steam could power a train. This is why you don't do this. This is dumb. Well, you do this with the proper equipment, and you don't heat things way too hot when they have dangerous stuff like this in it. Although, I don't think it's as caustic as it seems to be hyped up to be. So far, it's been, like, the most caustic it's been is when it reacted with the aluminum to make sodium aluminate. But if it did react with the glass, then that implies that it's incredibly caustic, because glass is pretty inert, and, you know, although it's so caustic, I did not get, like, I don't know, I didn't get any of it on me or anything, so And if I did, it was like so negligible that I just don't notice it. Because fortunately, when that thing exploded, I was safe. Okay, I was fine. So that leaves me with the final thing, which is the product. Sodium hydroxide is, they sell it as like beads or like other things. You can get it as a powder, and it is a white powder, which is, kind of suspicious. But no, this is sodium hydroxide, as far as I'm aware. To test it, if it is sodium hydroxide, you need to test if it's a base, because sodium hydroxide is a very strong base. So to test this, you could react it with aluminum. If you dissolve it in water, react it with aluminum, because sodium hydroxide obviously reacts with aluminum. Reacting the sodium hydroxide with an acid, a strong acid, I'm pretty sure, would show us if it's, obviously, because bases react with acids. Or you could just buy one of them pH testing strips and, yeah, I mean, that's expensive, though. Who would want to do that when you could just pour some vinegar on this and see what happens? Something else to note about sodium hydroxide is that the sodium, like a lot of other first-row elements, usually bonds in a certain way that it's able to be used as an electrolyte. What I mean by that is that if we were to draw this as like a skeletal diagram, there would be a plus on the sodium, and there would be a minus on something holding the sodium in there. As those first row, they only have one valence electron, all of them. So they want to try to gain an electron. That's probably why there's a plus there. And that action of taking another electron from something else basically allows it to be part of the compound. So electrolysis is the basis for most batteries. And I say most because, I mean, I'm sure there's an exception that I just don't know about. But in an alkali battery, the electrolyte is usually potassium hydroxide, and usually the metals that are being used as electrodes react with this, and they can cycle. They basically cycle between, you know, being in a certain state with the electrolyte, so that way it lasts for a very long time. And, yeah, it's pretty good stuff. We'll talk more about batteries in the future. But that's all I have for now. I'll see you all, later, I guess. I don't know.